So a quick revision of atomic physics. Every material which consists of atoms, and atoms are the very small particles which consist of neutron, proton, and electrons. Neutron and protons are within the nucleus, known as nucleons, and around the nucleus, a lighter particle, electron, move. And the number of the proton and electrons are equal as the whole atom is electrically neutral. The composition of the element changes, the composition of atom changes as the element change. So different elements, the main identity of the element is a proton number. So as the number of proton changes, the element will also change. Like here you can see the first one, it is helium, which is having 2 protons, but then lithium is having 3 protons. Number of neutron can vary, but the important identity of the element is the number of protons. This is a nuclide notation, means how we represent a nuclear, how we represent an atom. A is known as a nucleon number, which is a sum of neutrons and protons. So A is actually a sum of neutron and proton, and Z is representing the number of protons. And if we want to find the number of proton, that is given by this number, atomic number Z. To get the number of neutron, we take a difference, so 12 minus 6, so that is 6. And because it's a neutral atom, so electron and proton should be same. If it was a charge, a positive charge, so proton should be higher, and negative charge, then number of electrons should be more. Then isotopes, atoms having the same number of proton but different number of neutron, or same atomic number but different atomic mass, we call them as isotope. Like here it contains 1 proton and 0 neutron. 1 proton and 1 neutron. How to get the neutron number is by subtracting. And this also contains 1 proton and 3 minus 1, that is 2 neutron. So they have the same number of the protons, but they have different number of neutrons. What we call them as isotopes. And isotopes have the same chemical properties because they have the same number of electrons. To find the structure of an atom, Rutherford performed an experiment. What he did, he took a gold foil or a metal foil, very thin metal foil, and he targeted this by alpha particles. What he observed most of the alpha particles penetrate or pass through. Few of them changes a direction and few of them bounce back. So if most of the alpha particle pass through, what he concluded, he said that atom mostly is empty space. Most part of atom is empty. Few of them deflected. So he suggests that there's a nucleus, the central part nucleus is there, which is having a charge. And the third one, few bounce back. So he suggests that there is a mass in the nucleus. That's why few of the alpha particles are able to pass through. Then the term radioactivity. Radioactivity means it's an emission of a radiation by unstable nuclei, because the nucleus is very small. So as the number of the particle increases, the nucleus becomes unstable. Like it will have many protons and neutrons inside. So it will be highly populated and it will be unstable. As a result, the nucleus start to emit out 3 types of radiation. One is called alpha, means 2 protons and 2 neutrons together. Another one is a beta, which is only electron, and the third one is a gamma, which is energy. So alpha, beta, and gamma emissions are there, and these radioactive emissions are random and spontaneous. Random means there is no order. You cannot predict which one will be the next radiation or how much time it will take for a next radiation to come out. And spontaneous means it is not affected by any external condition like state, temperature, pressure, does not affect the amount of radiation from the source. So 3 types of radiations are there: alpha, beta, and gamma. Then what happened in alpha decay? Because in alpha, 2 protons and 2 neutrons will come out. So what happened to the mass number, the nucleon number? Example for polonium. Plutonium, it is 240, so it will become 236. And what happened to atomic number? It was 94, so it will become 92. Because the atomic number changes, the proton number changes, so whole element will also change. So journal equation, the nucleon number always decreases by 4 and proton number decreases, or atomic number decreases by 2. And this is a symbol for alpha, which is also known as helium nuclei. So atomic mass decreases by 4, atomic number decreases by 2. So here it was 230, emit out alpha become 226, and 90 become 88. So this is decreased by 4, this is decreased by 2. Same thing, uranium, which is 238, become 234, so decreased by 4, and this decreased by 2. This is what happened in alpha decay. In beta decay, what happened? One of the neutron breaks into proton and electron, and this electron is a beta. So proton remain in the nucleus, and this electron goes out from the nucleus. So as a result, what happens if the proton remain in the nucleus? Proton number will increase. But the nucleon number does not change, because the nucleon number is a sum of neutron and proton. One neutron decreases, one proton increases. So as a result, there will be no change. So journal equation for beta decay, the nucleon number remain the same, and proton number or atomic number, it always increase by 1, and this is a symbol for beta. So here cesium is there, 137, remain 137, but why the element changes? Because the number of proton changes, it increased by 1, so 55 will become 56, and this is a symbol for beta, and there is also energy release. Same thing, a radioactive element carbon is there, so nucleon number remains same, but the proton number increases by 1. Lead is there, the nucleon number remains same, but proton number increases by 1 if there is a beta decay. And gamma is just an emission. Gamma, there is no change in atomic number, no change in atomic mass. So element remain the same, it just release the energy. Then this table is very important, which is about the properties of alpha, beta, and gamma. Alpha is having 2 proton, 2 neutron, also known as a helium nuclei. Beta is only electron, and gamma is the electromagnetic radiation. The charge, the mass is 4. Why? Because 2 proton, 2 neutron. The mass is same as like electron, 1 divided by 1840 or 2000, you can say. This is a relative mass. And gamma is not having any mass. Charge is +2, -2, and neutral. Speed, alpha is slow, beta is fast, and gamma is the faster, like travel with the speed of light, which is 3 exponent 8. Ionizing ability, tendency to remove electron or knock out electron from an atom, because alpha is having more mass and charge, so it is having the highest ionization. Penetration means the distance traveled by this radiation, because alpha is traveling slower, so it will have a low penetration as compared to gamma or beta. We can stop alpha by using air or even a paper. We can stop beta by using aluminum, few millimeter aluminum, and we can stop gamma by few centimeter lead. Alpha and beta are deflected by the magnetic field because their charged particles are there. As their charged particles, they are deflected by magnetic field. Both electric and magnetic field. So penetration power, because alpha is having a small speed, so it has the least penetration. So alpha can be stopped by paper, beta can be stopped by aluminum, and gamma can be stopped by few centimeter lead. Interaction with electric field, because these are charged particles. So alpha particles are positive, so they are attracted towards the negative plate. Beta particles are negative, so they are attracted towards the positive, and gamma does not have charge, so it will pass straight. And one more point you have to keep in mind, that see the deflection of a beta or curvature of a beta is more than alpha, because beta is having a small mass, so it can deflect more. Alpha is having a large mass, so it will deflect less, like difficult to deflect. Then deflection in a magnetic field for alpha and beta. So for alpha, we will use left hand, and for beta, we'll use right hand. So index finger point towards south, second finger represent the direction of a particle, and thumb will show the direction of force or deflection. So remember, alpha, you will use the left hand, and for beta, you will use your right hand. So magnetic field, index finger point towards the magnetic field, which is south. Thumb will select particle direction is by second finger, and thumb will represent the direction of deflection. So when you apply the rule, your index finger, because cross means magnetic field is into. So your index finger should point into, your second finger should point upward. And what you will find when you're using a left hand, so alpha will point in this manner. And beta will be opposite. You can use the right hand, or you can use the understanding that beta will be opposite of alpha. So it will deflect in opposite direction. And beta should have a large deflection, so greater curvature compared to alpha, and gamma is not having any deflection. Then there are radiations in our atmosphere. We call them as a background radiation, radiation other than the source. So what are the sources? The cosmic rays, the radiation from outer atmosphere, the food, ground, medical, and radon gas, which is there in our atmosphere, contribute to about 50% of the background radiation. So radiations other than the source which are present in our environment are known as background radiations. Then what is the concept of a half-life? The radioactive sample, when it starts to emit out radiation, it gains stability. So time taken by half of the sample to be stable is known as half-life. So example, if we have say 100 gram of sample was there initially, half of 100 is 50, then half of 50 is 25, then half of 25 is 12.5. So how much time 100 will take turn into 50, or 50 will take turn into 25, or 25 will take turn into 12.5? That is known as half-life. And the activity will also decrease. Like example, original activity is A. After half-life, it will be A by 2. After another half-life, it will be A by 4. After another half-life, A by 8. After another half-life, A by 16. So after every half-life, the activity or capability of the radiation or radioactive sample to emit out radiation will become half. So we can use no, it won't be A by 6, it will be A by 8 because it is half. Like first it is A, then what is half of A divided by 2, it become A by 2. Then A by 2 divided by 2 become A by 4. A by 4 divided by 2, because when you divide by 2, you will find A by 4 divided by 2, it will become A by 8. So after every half-life, the sample will become half of its original value. So in the beginning, if we have 100 gram of a radioactive sample, after the half-life, 50 gram of the sample will be stable and 50 gram of the sample will be unstable. The total amount will remain 100, but 50 gram will be unstable and 50 gram will be stable. Then same thing, this 50 gram which is unstable will further emit out radiation. This 50 gram which is unstable will further emit out radiation, and it will turn into 25 grams unstable and 25 gram stable, and already we were having a 50, so it will become total 75. So proportion of a sample which is stable and unstable will start to decrease. So the one which is unstable start to decrease and the one which is stable start to increase. So after every half-life, the amount of a sample which is radioactive become half of its original value. It's not like the total sample will be half. It means amount of radioactive sample will be half. So if it is 100 gram of a sample, after half-life, 50 grams will be stable, means will not emit out radiation, but 50 grams will continue to emit out radiation. So this time interval, the time it takes to be half of its original value, we call that as half-life. Then out of 50, 25 gram will be stable and 25 grams will be unstable. So this time interval is also known as half-life. Then out of 25, 12.5 grams will be stable, means will not emit out radiation, and remaining 12.5 will be unstable. So this time interval is also known as half-life. So the idea of the half-life is the time taken by half of the sample to disintegrate or decay. So we can use a decay curve. We can use this graph to work out the half-life. So first example, if it was 100, then half of 100 is 50. So how much time 100 will take to turn into 50? That time is known as half-life. Same thing, 50, half of 50 is 25. So we'll draw a line from 25 and we work out what is the time. So you can see 100% radioactive, then 50% radioactive, then 25%, then 12.5, 6.25, 3.125. So amount of radioactive sample, which is radioactive, will start to decrease. Then the safety precautions when we are handling the radioactive source. So these radiations are harmful, can damage the tissue cells as they're highly ionizing. So what are the safety precautions? We should use a forceps or a tong to hold the source. We should not point the source towards the living tissues, and we should keep the radioactive source in a lead-lined box so that the radiation cannot escape. We should wear lab coats and using cover the body so that a person not exposed to radiation, as well as using robotics or remote sensors to handle the radioactive source. And then what are the uses of the radioactive isotope where we can use for a treatment of a cancer? That is called a radiotherapy. Gamma radiations are used to target or kill the cancer cells. That is called radiotherapy. Or you can also use to check the leakage in oil or gas pipelines. What we can do, we can just inject the radioactive sample into a pipeline. So if there's a leakage or a blockage there, then that part will detect more radiations because there will be more source here. So we can identify that like this is a sensor and radiations are coming out from the source, which we add into a pipeline. So we can identify this is the exact position where there's a leakage or a blockage. And we can also use to check the thickness of the paper or a metal. So radioactive source is there and a detector. If a thickness will change, that amount of radiation which are passing through the sheet will also change. If the thickness decrease, the amount more radiation will pass, so detector reading will increase. If the thickness remain constant, the reading on the detector will also remain constant. Then the nuclear fission means when the heavy nucleus break down into a lighter one by the help of a neutron is known as nuclear fission. So we target the heavy nucleus by neutrons, so split into lighter nuclei and give out neutrons as well, more neutrons. This nuclear fission happens so this is the equation for nuclear fission. Uranium is there, 235 we target by a neutron, form two different elements and a neutron, three more neutrons in energy. It's a chain reaction, nuclear fission, like because it produced three more neutrons, so they can also contribute to greater number of fission or increase the number of fission. Fission happen or we carry out fission in a nuclear power station, whereas nuclear fusion, this is a nuclear fission reaction, like where we carry out a nuclear fission reaction which produce heat energy. That heat energy is used to convert water into steam. As a result, steam rotates the turbine. It connected to a AC generator, which produces electricity. And a nuclear fusion, when a lighter nuclei join together to form a heavy nucleus and emitting out energy, is called nuclear fusion. That happens on stars like sun. Also, it's producing enormous amount of energy by hydrogen fusion. It can be helium fusion as well, but on the sun right now, it is a hydrogen fusion.